跑起来我走路。我感觉不是。没有，你来有。昨天是哪的这个还是不断的是。我那边也是你的肉的嘛。周末是带我们来的。很感动哎，这个。这拿了吗？你知道他们呢？干嘛？等一下哦。什么来着？讲个10的那个。OK OK。我做了2次，打也不一样。OK。因为都是一样的，打你。变人都是感谢归真。哦。对。Hello。我玩等天天话，根本有。有没有名次的？对，我这位分推是吗？会。呀。没有佛翻是真的，但是跟跟这个课没有关系。这个东西是真的，但是啊、跟这个课没有关系。那给你看啊。哎，你们两个是兄弟嘛？铁弟。父子。都姓方啊，是吧？很像哦，很像，很像哎。哎，4天。 testing。诶，为是管天？管天呢？不叫管天吗？管天呢？照给他看，表情，照给他看，对不对？So later in the second hour, we will give the quiz back. Discuss first. You want to discuss first? Later, later. Later. I will discuss when the class want to finish. So the result 0 to 30. Anything, all the marks got people obtain. I mean, between 0 and 30, every marks like has someone get it. Yeah. So and the mean is around 17. Standard deviation, let me see, 8.5. Very bad. Yeah. Mean okay, 17. 17. Above half. I got 6 of you got full marks. 6 of you, I think, if I'm not wrong. 6 of you. Not good, I think. This. But for those who get 10 below, right? You really need to work hard, and then please find me for help if you need. Okay. Please. It's not late to start now, so please start. Okay. Hey, remember that last time we are checking this whether this series is convergent or not, and then we compare to 1 over ln n, right? We compare to 1 over ln n, and then we try to integrate 1 over ln n. Okay. You can use some advanced method. Okay, use the power series. We will learn later. So we can do some substitution. Okay, and then we get e to the power y over y. Okay, once we got this right, we can express e to the power y in terms of polynomial of y. Okay, in that case, we can integrate term by term. Okay. Now I just want to tell you there's something like this. We will see really soon after we finish series. I mean, finish the convergent test. We will see power series stuff. You will see this again. Okay. And then you will be integrating this polynomial. Okay. And then this polynomial integrate to infinity, from 0 to infinity. Okay. I already posted out this note, okay, for yesterday. Yesterday? Yesterday, yeah. Yesterday. You can check out the lecture 13. I already posted up. Guan Tian is here. Okay. Okay. So we continue with the absolute convergence. Okay. So if both infinite series of an and absolute value of an both converges, we say that the infinite series of an converges, absolutely convergent. If the infinite series converges, but the absolute version of the infinite series diverges, we say that an is the infinite series of an is conditionally convergent. Okay, so what's the most important example for series that is conditionally convergent? Anyone still remember? What series is conditionally convergent. Okay, the alternating harmonic series. Okay, so the alternating harmonic series is convergent, but the absolute value of the harmonic series is divergent because harmonic series diverge. So we say that alternating harmonic series is conditionally convergent. Okay, this is one single example that you have to keep in your mind. Okay, because we invent this notion here. Okay, so at the end of our last class, we introduced this absolute convergence test. Okay, if the absolute value of an infinite series defined by the absolute value of an converges, then the infinite series of an converges, right? Because if you add up all the positive number, you already converge. Okay, so no matter how you place your sign between the an, it's still okay. I didn't tell you why it is true, but you can remember in this sense. You don't want to know. Sure, you don't want to know. Okay. You don't need to know. You don't need to know. Okay. But what you need to know is this statement here. Okay. This statement you need to know. Have to know this statement. Okay. What do you want to know? Sure. Okay. So let's show for this. How to show that this infinite series converges by using the absolute convergence test. Any idea? So you look at the absolute value of the an. Okay. So consider the absolute value version of the an. Okay. So you need to ask whether this converge or not, right? If this converge, then the infinite series we with the modulus removed also converge. Okay. So what's this here? It's 1 over n squared. P series. Okay. So P series. This P equals to 2, which is 2 greater than 1. Okay. So P equals to 2 greater than 1. So it converges. Okay. So if you have a P series, so P series is the infinite sum of 1 over n to the power p converges if and only if p is greater than 1. So since the absolute version of this infinite series converges by what test? By the absolute convergence test. Convergence test. The alternating 1 over n squared also converge. Yes. Okay, so this is one of the example. Converges. So does this converge absolutely or conditionally? Hey, why? You just say what you want to say. Is it? So why converge absolutely or conditionally? Absolutely. Why? Why converge absolutely? Okay, because both series and the modulus version of the series converges. Okay, if both converges, then we say that the infinite series of an converges absolutely. Okay, so in particular, this series here converges. It is absolutely convergent. So both the absolute version and the non-absolute version converges. Okay. Okay. So far, good. So next, determine whether this series is convergent. Okay. So what to do here? What to do here? So follow the same idea, right? Because this example is following the absolute convergence uh, test. So can we look at the absolute version of the AN? If you look at the absolute value of cos n over n squared, what can you relate to? Bounded by what? Cos n is bounded by what? 1 minus 1, okay? In particular, the absolute value of cos n is bounded by, by 1, right? Okay, so cos n, okay, so I want to say that, so since cos n is bounded by 1 and minus 1, okay, the absolute value of cos n is bounded by 1. Make sense or not? Okay, very good. On track, okay, I go faster. So this is less than equals to 1 over n squared. Okay. So why we can remove absolute value from n squared? Yes, because the n we consider is 1 to infinity, and you consider the square of the number. So it's always positive. Good. So can you deduce anything from here or not? Once you got this? Sure, P series. So what do you want to say? So that this and the series, the inference series defined by 1 over n squared converges again due to E series, due to E series where greater than 2, sorry, P equals to 2, which is greater than 1. And then what can you deduce? What converges? What test? What test you're using? Hmm, comparison test. Okay, so the which comparison test? We got two comparison tests. Ordinary or the limit, huh? Yeah, the direct or the ordinary comparison test. So by the ordinary or the direct comparison test, the infinite series defined by the smaller sequence converges. Okay. In particular, after you know that the absolute version converges, what else can you deduce? The infinite series without the absolute value also converge. Okay. So by absolute, okay, I just write the short form absolute convergence test. Okay. The infinite series of cos n over n squared also converges. In particular, it converges absolutely or conditionally? Absolutely. Okay. So because both the absolute version and the non-absolute version also converges. Particularly, absolutely. Okay, good. Any question on this cos n stuff? cos n over n. Okay. Next, this series converge or not? Hmm? Sure. So let's try the technique again. So let's look at the absolute version of the an. You get 1 over square root n. The infinite series defined by 1 over square root n converge or diverge? Diverge, right? Because the p is less than 1. Okay. Yeah. So you cannot use the test because this is divergent. Sorry? Divergent test or test for divergence. Test for divergence, what do you need? So if the infinite series, so let me use another. Infinite series converges, limit so equal to 0. Then okay. So if you want to use this, you need to show that if the limit of an is not 0, okay, not q implies not p. But you take this also limit to 0. Okay. Okay, so what we know. So let's write down what we know. The infinite series of 1 over square root n diverges due to p series where e is equals to half, which is less than 1. Okay. Hey, where's Jinghua, by the way? She's the one who insisted this physical class, right? She said, if we go online, we don't learn one. Okay, sure. Okay, next. So how? What kind of test we can use on the series? What kind of test? What is the other test we can use on alternating series? Huh? What's that? The test called? What's the test called? Alternating series on Taylor for alternating series on. Yeah, Taylor, not Taylor series. I mean, built purposely for the alternating series. What's the test? What's the test? What's the test name? Hmm? AST. Alternating series test. Okay, good. So alternating series test. Okay, what does alternating series? Alternating series. Okay, minus one of n, maybe plus one of bn. Okay, if this alternating series satisfy how many property? Oh, so many. Okay, two property. Okay, first property is what? Decreasing bn, right? Your sum must be decreasing. Okay, the thing inside your summand is decreasing. Bn is greater equal to bn plus 1 for on. Okay, and then what else? Not just decreasing. I want to decrease all the way to 0. Okay? Decrease all the way to 0. Okay, if satisfy these two property, then the alternating series converges. Okay, so let's see if we have these two property or not in this case. Okay, so let's check. Okay, so we have what? So our alternating series is the sum of n equals to 1 to infinity of what minus 1 to the power n plus 1. Okay, so this is our alternating series. So first, do we have 1 over square root n is greater or equal to 1 over square root n plus 1? Okay, this implies what? Square root n plus 1 is greater or equals to square root n. Okay, which means what? N plus 1 is greater or equal to n. Okay, so which is true. Okay, good. We got the first one. How about the second one? Limit of 1 over square root n. Is it equal to 0? Yes, right. Okay, because this is the continuous limit of the 1 over square root x function, okay, which converges to 0. So we have this property. So by alternating series test, the alternating series of 1 over square root n converges. In particular, it converges absolutely or conditionally. Absolutely or conditionally? Conditionally. Why? Because why conditionally? The original one? What do you mean by original one? The absolute one diverges, right? The absolute one diverges, okay? The alternating one converges. Make sense? Okay. So in particular, it converges conditionally. Okay. Finish this absolute convergence up. Any question or not for this converges absolutely or conditionally? Okay. Okay. So next is called the absolute ratio test. Okay, absolute ratio test. So we look at, instead of comparing different series, we just have one series here. Okay, this is the one that I love the most. Okay, you just need to compare an plus 1 and an term and look at the ratio. Okay, so the limit of n to infinity absolute value of an plus 1 over an. Okay, and then you see what this limit equals to. Okay, if it is less than 1, okay, then the series converge absolutely. If the L is greater than 1, then the series diverges. If L equals to 1, you cannot conclude anything. You don't know anything about this series. Okay, so less than 1 converges absolutely. Greater than 1, the series diverges. Okay, every time the first thing I will do on the series test, the series is using this. I think this one is most applicable one for me. Yeah, for me. Yeah. Okay. Okay. Let's see how powerful is it. So if we want to show that this converges, right? Okay. Absolutely. Maybe you want to use AST, or you want to use convergence, absolute convergence test. So let's try with this ratio test. Okay, let's try with this ratio test. So what we do is we find our AN first. Okay. What is AN here? Okay. Our AN is minus 1 to the n plus 1 of 3n over n factorial. Right? Okay. So we want to study the ratio of an plus 1 over an, and then take the modulus. So let's study this ratio here. So what do we get for this ratio? This ratio of sequence. So an plus 1 is what? You just add n by 1. So at first sight, right, you might see so many factors, but it is kind of uh, satisfying that after you take the quotient. So let's see what happens. Okay. So can you cancel anything? So this three. So let me write more stuff. Let you see what is going on. Okay. So what is this really? So we have minus 1 over n over 2, 3m's times 3. Okay, we break this down. And then what is n plus 1 factorial? It's just n plus 1 times n plus 1 and so on, multiplied by n factorial over minus 1 to the n plus 1 times 3n. Okay, you can see that they share quite a lot of similar terms, okay, where we can simplify them. For example, n factorial, top and bottom, so we can cancel it. Okay, so we can cancel it. And we also have n at top and bottom. We have n plus 2 minus 1 at the top and n plus 1 of minus 1 at the bottom. So what do we left with? We left with 1 minus 1 here. Okay. So in the end, what do we get? So we just get minus 3 over n plus 1. Okay, absolute value of it. So which means we will get 3 over n plus 1. So what's this limit here? It is just 0. Okay. So since this L is less than 1, right? Less than 1 by the absolute ratio test, the series converges absolutely. Converges absolutely. Okay. Less than 1 converges absolutely. Greater than 1 diverges. Equal to 1 is inconclusive. Any question? Hey, what do you mean by do absolute first? Oh, you mean you mean is mean if this one is equals to, you mean like this first? I think you can. It matters, but they are the same. Yeah. It matters, but they are the same. Yeah. So you can yeah, like what Yishun say, you can just get rid of this minus first. Because in the end you will get rid of it. No matter how, because you are taking absolute value. Okay. Yeah. So what he mean is this thing here is just equals to the n plus 1 over n plus 1 factorial over 3n over n factorial. It works. because everything coming out from here are just positive number. It's really the same. Okay. Question? No? Okay. Forward. Okay, how about I let you try the next one? So I'll let you try for 3 minutes, this one. There are 4 n here. There are 4 n's here. Try it. N factorial, n to the power n. Ratio test, see what you get. First, find your an first. Okay, find your an first. Yeah, try write it down. See what limit you get. Yeah. Attendance, no worries later. Yeah. Hmm? Ratio test? Yeah, ratio test. Yeah, keep track of your n. How many n you have? Yeah, so many n. Can you cancel any of them? Or not? Does anyone get to this stage already? Huh? What do you get in the end? 1. How about this stage? This stage, what's the next stage? What's the simplified fraction? Huh? So you can cancel the factorial stuff. What else? And these two cancel or not? N plus 1 and n plus 1 to the power n plus 1. Huh? Can, right? You got n plus 1 times of n plus 1. So you get rid of one of them. So what do you get? You get n plus 1 to the power n over n to the power n. So what's this? They have the same power. So what can you do? You can combine them. Okay, so the question is, what is this limit here? What is the limit of n plus 1 over n? Or maybe sometimes more familiar with 1 plus 1 over n to the power n. Yeah, I think this one you need some stage to show it. This limit here is e. Is e. Yeah, okay. I think this limit you need to learn. Okay, it's not easy, but you need to learn. Not too hard. And you need to learn this. This is e. So this one, some need to be done. Have you guys compute this before? This limit before? Yeah. Some work need to be done. Not too hard. But okay. Never mind. You go and find it back. Okay. Can use directly. Yeah, can use directly. Yeah. Okay. So E is greater than 1. So what happened in the ratio test if you have L greater than 1? The series diverge. So test. So the series diverges. Where's the series? This one. Okay. So next is root test. So root test is similar to ratio test, okay? But what is this going on? So um sorry. Oh, okay. Haven't finished. It's okay. Just give. Yeah, just give whatever you like. But need to be honest, huh? Need to be honest. Yeah. Need to be honest. Don't sabotage, need to be honest. Huh? Okay. Okay. Done. Done, Okay. Okay, next. So root test. Root test is similar to ratio test, but we take n root of our an. Okay. And then we look at the limit. If this limit is less than 1, series also converges absolutely. Greater than 1, also series diverges. Uh, the limit equals to 1, the test is inconclusive. Okay. So notice the similarity between the ratio test and root test. Okay. But in root test, we just had n root of the absolute value of an. Okay. So let's see how this works. So this root test, right? It really useful when you see some power of an terms. Okay, an terms that include power of the sequence. Okay, because you can imagine that we got the power of n here, right? After you take the n root, this power will disappear. Okay, then it becomes some usual sequence we see before. So let's see how we use this. So our an is what in this case? Is just 2n plus 3 over 3n plus 2 to the power n. Okay. And then we look at the limit of this absolute value of 2n plus 3 over 3n plus 2 to the power n. And then you take modulus. And then you take the n root. Okay, so you are n rooting a modular stuff. So how to do this calculation here? Let me move this up a bit. Okay. Yeah. Can you remove the absolute or not? Why? Yeah, because always positive again. Okay, this number is always positive. So you just remove the absolute value. So you just get 2n plus 3 over 3n plus 2 to the power n. Okay, power n taking n root, so you're left with the fraction itself, which is 2n plus 3 over 3n plus 2. Okay, it is always. Okay, so can you compute this limit or not? How to compute this limit here? Times 1 over n. Good. Okay. So what do you get? 2 plus 3 over n over 3 plus 2 over n, which is just 2 over 3. 2 over 3 is less than 1. Okay, so if it's less than 1, then the series converges absolutely. Just absolutely. Okay. Yeah. So let me check something. Check something. Okay. So this file is not really important, but for your extra information here, not as not in the exam. Okay. Why so materialistic? Okay, okay. So ask it. No, I want to talk about this a little bit. Huh? It's fun, it's fun. It's fun. Okay, so I talked about this. So it's not example, but I want to talk about this. So by a rearrangement of infinite series, meaning we can simply change the order of the terms. Okay, we can change the order of the terms. So why we want to change the order of the terms? Okay, so it turns out that if the sum, okay, the infinite sum is absolutely convergent. So absolutely convergence means what? The absolute version of that series converges and the original series converges, okay? And have sum x, then no matter how you rearrange your term, you still get S, okay? And then the interesting one is second one. If this infinite series conditionally convergent series is conditionally convergent series, and R is any real number, literally any number, then you can rearrange the term inside your infinite series that has a sum equals to R. Okay? Convergent series that you know. What's the conditionally convergent series that you know? What's the example? 1 over n. There's a name for it. Harmonic series diverges. So alternating harmonic series. So if you take any number R, okay, maybe you take half, take 1/3, minus 1/3, you can have a rearrangement of the alternating harmonic series that give you that summation. Any number. You can map out any number using alternating harmonic series just by rearranging the term. Okay. Yeah, this is what I'm saying. Okay. I mean, I cannot show you the calculation. Huh? Why? No. Too long, yeah. Too long. Okay, I pause in there. I pause in there. I'll put the example up. Moodle, yeah, Moodle. Okay. Okay, I put the Moodle. I will write down the example here later. Okay. What do I mean by when to stop? No, any real number. Any, yeah, any, literally any. Serious. Seriously. Huh? No, you need to consider, okay, what I want to say is, alternating harmonic series is equal to any number, okay, after rearrangement. So after rearrangement. So for any real number, you can rearrange your term in the series and then you get that sum. It's kind of weird, but yeah, very surprising. Huh? R is any real number. You can make out from one conditionally convergent sequence. No need, no need. Also can. Negative also can. Yeah. Okay, how? How about we skip the summary? Skip this. Okay, so let's pick one of this to do. How about do the first one? Okay. So we have now learned so many tests. What kind of tests we have gone through? We have gone through tests for divergence. Okay. P series, geometry series, comparison test. Okay, ordinary comparison test, limit comparison test, alternating series test, ratio test, and then root test. Also, one more integral test. Okay. So there's a good thing and a bad news I want to tell you. There's a good news and bad news I want to tell you. So in the exam, you will be given a formula sheet, but the formula sheet only includes the tests. All the tests will be included. So it's like your quiz. So we won't give a curve formula. Okay. Formula in the curve section. But one you can for sure is you no need to focus on conic section. Yeah. So, but for the other, it's really similar to quiz one. Okay. Yes. Yeah. I cannot say too clear already. Cannot say too clear. uh, I cannot say not example, but it's not important for this time. The curve formula like the quiz question. The arc length, area, so all those, yeah, all those. Uh, 3D graph. No, you still need to learn those arc length, area, those surface area. Important. Like those questions like quiz one is very important. In quiz one, similar to quiz one is very important. 12.6 is what? Yeah, lah, those things. Yeah. Conic section, all those. Because you use conic section to build all those things. Yeah, lah, this already why you are very particular. Okay. Okay. Wait, you don't say 3D don't have. Don't say 3D don't have. It's the arc length, all those you need to consider. Confirm. Okay. Okay, arc length, area, all those you need to memorize those formula. It's like the quiz one situation. What do you mean? Oh. Okay, let me check again. I think pretty sure it's ground floor, I think. But let me check. quite a lot, 100 over classes, 100 over. I don't know. I seriously don't know. I haven't taught other class before. Okay, let's come back. If possible, maybe I give more in next time. Next time. So okay, so this let's look at this series here. Okay, before I take a break, let's look at series here. What series? What kind of test you're gonna use? Normal test or test for divergence. Okay. So you just look at the. So when you use test of divergence, right? What do you hope for? It diverge. Very good. It diverge. So you want to hope that the limit here is actually not zero. Okay. If it is not zero, then you're happy already. Okay. If it is zero, then you need to try other stuff. Okay. So what's this? One. So what's this limit here? This limit is just half, which is not zero. Okay, so not zero by the test of convergence, sorry, divergent. Okay, the infinite series diverges. Okay, how about second one? Use your instinct. Tell me what you want to use. Use instinct. Guess one. Huh? What? Same one. Wow. Same one. So let me think. Let me think. Okay, let us analyze a bit. So if you want to use limit, right? Okay, non-zero, right? So when does this polynomial stuff non-zero? Okay, you must have at least the numerator grow faster than the denominator. Okay, so what happened here? Yes, remember what I said today. For polynomial, right? What really matters is the highest degree term. So highest degree term at the numerator you have what? N cubed. Okay, n cube. So square root n cube is n. So at the bottom is n to the power cube of top is 1.5, bottom is 3. Okay, maybe you go to 0. So right. So test of convergence is not good here. So what we do last time when we see this polynomial stuff, think also can, but so last time we say that this is almost the same as what? This is almost the same as n to the 3 over 2, n to the 3 over 2 over 3n cubed. Okay, so this is what? This is 1 over 3 to the power n 1.5, 3 over 2 again. Is that right? Is that right? Okay, so what's this? P series. P series. This P series converge or diverge? Just simply say what you have. 3 over 2 is what? 3 over 2 is what? Greater than 1. So this P series uh, converges. So can you compare? Can you compare between these two terms or not? Can you compare between these two terms? Is there a way to compare? How to compare these two terms? The only hope you want to show for convergence is the converged one is greater or equal to this original sequence. So is this true or not? So is this true? So what can you do? So I want to do something special here. So what do we do? Yeah, what do we do? So this is our guess. We don't know it's true or not. What to do? What to do? Bit too big. Huh? What next question? What to do? How to bound this guy? How to bound this guy? This guy. So let's say we keep the highest power turn at the bottom. And then what should we put at the top? I put this. Then you will ask me how I get this, right? Okay, so how we get this really? How we get this? Huh? Simplify what? The square root. You mean this square root here? Simplify. Okay, so let's have a look. Let's have a look. Okay, so okay, let's look at the bottom here. I think bottom here is easier to say. Bottom here is easier to say, right? So 3n cubed is less than or 2. 3n cubed plus 4n squared plus 2. Okay, so when you take the inequality change. Okay. Okay. All right. So how about the numerator here? And numerator here. You can see that 9 to the n cube is greater than n cube plus 1. Okay. So why we pick 9? Why we don't pick 5, 4, 3, 2, 1? Okay. Because we can take the square root of 9 where we get 3. That's why we pick a perfect square then. Okay. Just 4 also can, I think. 4 also can. But later you will see why 3 is good. Here at the bottom. Yeah, I think 4 also work. Yeah. 2 over 3, oh, yeah, it's still the same. Yeah. Okay. We will see. We'll see. So does everyone agree why this is true? Yeah. Which one? Maybe. Yeah. We don't take this one, maybe. Yeah. Does everyone agree or not? Does everyone agree? So let me write it down. So for denominator, it's easy to say. You just need to get rid the lower degree because they all contribute to positive number. So you will reduce your fraction. Okay? So if you get rid of positive number in the denominator, you increase your fraction. Right? Okay. So one thing you need to remember is if m greater than n, greater or equal to n, then 1 over m is less than or equal to 1 over n. Okay, so when you take the fraction, the inequality swap. You need to remember this. Greater or equal to 2, but 1/3 is less than or equal to half. Okay. Okay. So how you pick this numerator is your choice. Okay, as long as you make sure that what you bound with is greater or equal to the square root n cubed plus 1. Okay, so what do you get? So you get 3 of n of 3 plus 3 over 2 over 3 times n cubed. Okay, which is what? Which is 1 over n to the power 3 over 2. Okay, so if you pick 4 here, okay, 4n cubed square root, I think is still also greater than square root n cubed plus 1. So you can you will get 2 over 3 here. 3 is 2 over 3 times n to the 3 over 2 also converge. Still works. Okay. Yep. Sarah? The first one is true. You mean the first inequality? So I already checked the numerator, right? So let's check the denominator. So y is square root 9 cube greater or equal to square root n cube plus 1. Okay? So this is true if n 3n cube is greater than equal to m cube plus 1. Okay, which is 8n cube is greater or equal to 1. But your n is starting from 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Yeah. So you can see from here, right? If you put what do you want to put just now? Put 4, right? 4 here. Okay. So you get 3 times n cube. Also works. If you don't put anything, mm, mm, yeah. Mm. Yeah, if you don't put anything also can. Then you have extra stuff here. Okay. Sometimes mathematics want to simplify stuff. You can say so. Yeah, you can say so. Yeah. Okay. Another thing want to make sure is the ordinary comparison test. You need to make sure both your sequence is greater or equal to 0. Okay. This is another thing you need to take notes. So what? So since the infinite series of 1 over n to about 3 over n converges due to p series with p equals to 3 over 2, which is greater than 1. So by simple reason test, the series of square root n cubed plus 1 over 3n cubed plus 4n squared plus 2 converges. Okay. Okay. Let me reduce this. Okay. How about this function here? How about this function here? No, right. This series here. 5 p.m. already. Take a break. Uh, take a break. You can. So in the break, right, I will give back this quiz. So I'll call your name one by one. You can get it, and then it's okay. You go to toilet, then you can come back and get it later. Okay. I'll call one by one. Okay. It's Chen Kaijie here. Chen Kaijie. Chen Kaijie. No. Hua Junwei. Hey, Hua Junwei disappeared for 2 days already. We're here already. Hua Junwei呢？转了。哦，是咩？Hey, but he still come for last few times. Tomorrow. 哎，我看到他 我看到他上课很专心的哦。
天我们是不专心。
没有，他坐很定，所以我看得到，他坐很定。他转向转坐在读什么？现在？怎么这样容易进呢？学校要转就转了。OK。Berwin。有 quiz。Hey, do you have difficulties understanding the lecture? Some of them. Some of them can manage it. Can manage it. Okay. You try to do those exercises. Okay. If you don't know, you just Teams message me. Okay. Or if you got time, you can visit me. Yeah. Okay. Okay. Keep looking. Still have a long way. Okay. Just message me if you have any problem. If you don't understand the lecture now, so you can. Okay. Okay. Yeah. Okay. Yeah. I think not here. You sound fake. 孤城者。Difficulty understand the lecture content.
Yeah, I can do compilation. That's the problem.
Oh, that's
Yeah.
Okay. Have you done those
Tutorial.
Yeah.
Yeah, 5.
Have you tried?
5.
If you think you spend too much time, you can study the answer and see how they try to understand. The Adams, I posted the other two. So are you a retake? We are retake. So you take this from the phone. What do you think? Do you understand better?
Better in calculus 2, but I think the calculation is.
Yeah.
Yeah. What I'm doing more.
Okay, you do. Oh, okay. Then you need to really pick up the skills. Yeah, all the.
Learning the skills in
Yeah.
calculus 1.
Yeah. I mean, one. You mean you have difficulty integrating, differentiating, right?
Yes.
Yeah. You need to pick out. So what I suggest is you try and learn some basic integration.
Only basic. Basic. Here are
Yeah. Oh, then this is the trig stuff.
Yeah.
You need to look for the chapter that have trig. I also always forget it, but you need to remember where to look for.
Okay.
Yeah. It's okay to forget, but you need to always.
Say 4 marks.
Later we'll discuss and then you will see if you can learn some more.
No. I mean 4 marks for this whole
30.
30.
Yeah. Okay. You take it first. 苏泽辉。岳夫玉。Hello. Do you have difficulty understand the lecture? Oh, okay. Do you have any difficulty understand the lecture? Who are you? Song. Yeah, not your Fu Yu. Okay. Your Fu Yu. 理赔。 Hi. So, do you have any difficulty understand the lecture content? Huh? You can't remember the formula. Try do the question in the tutorial. Yeah, if you don't want to do right, I posted out the Aiden solution manual. You can look at the solution, see if you understand. They have similar questions there. But try and do some calculation. Is it okay? Okay. How do you find the course? Do you understand what I say? Or is it hard to understand? Hard to pick up?
Mostly I understand
Just haven't tried. Yeah, you need to practice more. Max is you have to practice more. Otherwise, it's hard to do the calculation. Yeah. If you have any problem in calculating, you can just message me. Just see. Is it okay? Okay. 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 Now. 多奇症，申浩伟，刘佳明，哎，有问题吗？我的理解那个没问题。有做练习吗？没有做，没有做很难会耶。啊，要做哎。
对。
OK， 不然的话你就先读那个 Adams 的练习的档。会，或者一个另外一本书的对不对？所以你就先学一下 ，OK 吗？
对。
不过一定要做哦，一定要做，不然的话很难学的会。对，就算你听了，但是你没有真正去算，你要做一些至少。你不用做完，你如果真的没有时间，不用做完所有的，你就做几题，前面几题，后面几题，中间题，可以吗？
对。
可以啊。
这个是我。
哦，这个是你的，你怎样听得懂我在教什么？
包括跟得上，还是要
有做练习吗？
有做一部分。
OK， 这样的话，再做多一些，让自己那个熟悉一下。所以你是 retake 吗？
不是，
哦，你不是 retake 第一次。
之前 retake 别的课程，然后把这个课程弃掉了。
OK，明白。
对。
对，要多，
然后一直没有到干，不得已在大干在这边。
对，多做一些练习。
所以现在我搞的前一部分的已经完差不多了。
对，要温习。
我前一部分大一学的，然后隔了1年才学的，已经忘很多了。
我只这个，看一下啊，你是什么？你是什么？有福利啊？你是什么？呀，你们有问题吗？没有复习到。OK， 有做练习吗？没有做完，不用紧，前一天没问题。OK， 没问题。要做多一点，不然的话。OK， 可是你们听得懂上课那种？因为他老师高点出过。OK， 你们不是 retake 是吗？因为我们他不是考太久，考要 OK， 我们就不要这个 OK， 就一下不行。要重温，我自己都会忘记这种给你我跟你讲，加油，再做多一点。如果有问题，你就 message 我吧。可以吗？可以的，做不可以？可以的，一定可以的。回去了。OK 了，就是上面 OK 啊。刘小红，李杰，Daniel。You guys having problem understanding the course of this is okay, but score. Yeah.
But for the sector, I think for the sector.
Okay. Have you?
No, still maybe with the exact.
Practice.
Oh, so all
It's okay. Solve one by one. One by one. Solve it. Okay, you cannot solve it in one go. Solve it one by one. If it is integration or differentiation problem, then you need to refer back. What you did. Yeah. Okay, no problem. So I forget how to. So refer back again.
Yeah, I already forget the volumetry.
So yeah.
Forget and then like
Yeah, so you pick up. So whatever we did in the class, you cannot follow the particular step. You pick up. Yeah, pick up the step. Yeah. You know your problem. You don't know. So you know all these formula. Okay, later we will see what here. See if you can get that number. Later we'll. Okay.
maybe it will be keep the formula in the exam, so we have on mark for the formula. You will have to out for the formula. If the answer is wrong, it will just you.
Oh, if the step is correct, then we will give some. If the answer is wrong, the step correct, answer wrong, some partial. First of all, you need to get the right step first.
Also, like just write the formula. Is it done as a
Sometimes we'll have marks, sometimes we'll have definitely just one or two. So try to learn computation. Okay.
after this you will give the
Yeah, I'll discuss straight away after this.
discuss and then what's in the
Yes, possible.
thank you.
Okay. So 王宇轩，梁叶，林水龙，赵怡轩，有点危险哦，黑鱼，昨天几吗？都讲。这不是我的。对，你是谁？两页。OK。有点危险啊。可以，等下可以 OK 吗？是吧？练习。
有多一点。
对，你在我点，来我，等下再看看有没有分点。汪真用，this guy write Chinese name, I thought this is only done in first year. Okay, you still first year. You very second stem already. You still write Chinese name. Third stem already. Okay. Wang Pei Wu. Write English name, Pei Wu. English name. Okay. Yeah. Ming Kai. OK 吗？有问题吗？你要对是吧？看你蛮专心的哦。没有不行。杨金荣。吴俊宇。 continue。施杰生，施杰生，施杰生，施杰生有啊，施杰生有。这个押进来，施杰生 ，OK。喂，要，花为要。刘拼音，刘拼音。梁耀庆，梁耀庆，梁耀庆，梁天意，刘拼音哈，梁什么？耀庆哈 ，OK。好，梁天意，梁天意 ，OK， 梁天意。林议会，林议会，林议会。文平，嘉县，龚嘉县，龚嘉县，check 一下，等一下我们会讨论，这些有 extra。学掉。县，关天，关天，丹泽义，丹泽义，洪明，洪明，高金汉，高金汉，高金汉 ，OK。宋浩，宋浩 ，OK。切胜，就切胜。方舟，方舟，不要再玩 game 了。张云，张云，张云，张云，这边方舟。高七笑，高七笑 ，OK。多威浩，多威浩，你是谁？哦，你是张宁 ，OK， 好。多威浩来。张一照，哎，张一照啊。金话，金话，金话，金话。刘一顺，刘一顺，刘一顺。银铃，彭银铃，彭银铃，彭银铃，彭银铃 ，OK。安青肉，青柔。江宏宇，宏宇。龙林波，龙林波。
江宏宇。
豫章，李豫章。郭嘉胜，郭嘉胜。谢宇轩，谢宇轩。these are all above 27啊。Terrorism 镇啊 ，Terrorism 怎么念啊 ？Burden OK。Above 27。One Silong， One Silong。OK，good。周子康 ，OK，good。周子康。易顺，易顺。来。Later I will discuss, then we will see. 彭香宇，彭香宇。Renis， Renis， Renis。Okay, above not above 30啊，30 is the top. 宋之飞，宋之飞。Who is 宋之飞？宋之飞 ，OK， good。刘佳琪，刘佳琪 ，good。黄子韬 go to toilet 啊。佳宇，梁佳宇那天。林天阳 ，OK, good. Okay, we will discuss. So we will discuss the quiz, and then you see the mark location. If you think that you should get more marks, you can argue with me later. But take a photo of your quiz. After the class, you hand back the physical copy. Okay, you hand back the physical copy. Take a photo later before you leave. So let's discuss the quiz. Okay, we ready? Ready to start? So this quiz here, we fix a setting of an n instead of particle, okay, moving in space. So first we have this polar graph r equals to e to the power theta. So first thing I ask you to do is find the point where this tangent line is horizontal or vertical. So at the horizontal tangent line, right? So what do you have to satisfy? Horizontal. Two things you need to satisfy. The horizontal, what do you have? dy theta, dy over d theta is 0, but dx over d theta is non-zero. Okay, so this one you need to check. You need to check every time. So you shouldn't say in your solution review exercise you have to check. So you really need to check. But for this question, why you don't need to check? Because when you check dx over d theta is 0, if there is no intersection, then that means must be non-zero. Okay, right? But you really need to check, okay, every time. Okay, you really need to check these two conditions here. So condition A and condition B. Okay, when you want to check for tangent line, horizontal tangent line. For vertical, you have the other condition. Dx over d theta is 0, but dy over d theta is not 0. Okay, because sometimes they just ask for horizontal, so you need to check two conditions really. Okay, so make sure you check two conditions. Okay. So one of the most losing point here is you don't list all the angle here. You only list angle between 0 and 2 pi or something like that. Okay. So if you have done some review question or tutorial question, right, it's because of the shape is repeating after 2 pi. So we just give up to 2 pi. But in this case, it's not repeating. So you need to give every point. Okay. Does it make sense? So you need to give every point such that the equation tangent equals to minus 1 4. Okay, not just in between 0 or 2 pi. So if you give only 0 between 0 and 2 pi, you lose 1 mark. Okay, so this answer here, right, makes sense after you draw this diagram here. Okay, after you draw this diagram. So initially, I wanted you to like draw this horizontal or vertical tangent, but some of you draw it quite nice. Okay, uh, Yi Shun one, can Yi Shun pass me yours? Yeah, this one is done on the spot. Don't tell me you cannot do on the spot. See, and then I show you. This is done on the spot or same day, same time. Okay, yeah. So actually, this is what I wanted you guys to do. But as long as you draw the general shape, you should get full mark. Now, okay. Renice, do you say that this one is the ratio, golden ratio stuff? It is actually a golden ratio after translation. Yeah, this is not golden ratio yet, but after translation, it is a. I didn't realize actually. After that, I only realized. Okay. Okay, this is actually what I wanted you guys to do it. Okay. Hmm. Yeah. So as long as you get the general shape, you will get full marks. Okay, no need the tangent stuff. Yeah, general shape from 0 to 2 pi. Okay, next. next, I want you to find the area bounded by both curves. Okay, and then I already shaded for you. So your task is to find the intersection and also find the right integration domain. Okay. So what you do here? Okay, so what you do here is really what you do is you need to split this area into this triangle stuff, right? Okay, so you can see that this part here and the other part here is only given by the polar curve r squared equals to 2 sine 2 theta. Okay, and then this area sector here will be given by the area under r equals to 1. And so you split into these two parts here. Okay, and then the rest you need to do the formula. Okay, you need to do the formula. So the formula that you need to learn here is a equals to half of a to b r squared d theta. Okay. So some of you did some calculation mistakes or maybe get marks off in the calculation. Okay, so if you get this setting right, you already get half of the mark. Okay. Later you show me. Later you show me. Okay. So if you have this formula, right? So you already get 4 marks. Okay, without computing. Okay, after you compute, you get another 2 marks, and then right answer, you get 2 marks. Okay. Next, what I want to test on you is calculate the arc length. Okay, calculate the arc length. So first, you need to give this formula up. Okay, so for example, this formula is not given in the exam also, so you need to learn this formula. I think who is the one besides Xulong? What's the name? What's your name? Yeah, what's your name? Huh? Ding Yi. Ding Yi, huh? I realized that you forgot what's the what square you need to put inside, right? Okay, so you need to remember what's the square inside here. So L is equals to a to b of square root of x dt squared plus dy dt squared plus dz dt squared. Okay, so you are taking the derivative. Okay, you need to take the derivative and then square it, and then sum of all square root. This question, huh? Okay, how I give mark for this question? So, first you give this formula. Okay, give this formula got 1 mark, and then this integration domain correct 1 mark, and then all the derivative correct 1 mark. Okay, and then all the computation to the correct answer 1 mark. Huh? Each derivative 1 mark. Okay. Okay. Can. Later claim from me. Okay, later claim from me. Okay. 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 And then the final one, I think is the easiest question if you know the formula. Okay, just plug in the number. Okay. So I already provide you the normal vector and also provide you a point on the plane. So what is the equation of plane? What do you need? You need a normal vector and a point. Okay. So the general formula is a times x minus x naught plus b times y minus y naught plus c times z minus z naught. Okay. So I give you x naught, y naught, z naught, and then I give you a, b, c. Okay. You just put it in. Okay. If you just give the general formula, you got 1 mark. And then if you give the right answer, is a full mark. Okay. So when we set out this question, right, exam question, right, we have some killer point. Okay. So this but this question here is a kind of free point. Okay, so you should get this free point. You can get it. So it's too bad. Okay, you should hold on to the free marks. Okay, these are free marks. Yeah, you let it go. Okay, so should hold on these 3 marks. Okay, any question you want me to go through again? Or you have any question or not? Okay, so I got a theme for my quiz, right? Any one of you know what's going on here? Huh? Does anyone know what is going on here? Okay, this is based on Ant-Man. Okay, Ant-Man is quantum mania. Okay, so what happened to this? Anyone can guess what story going on here? Does anyone? Maybe can give you 5 bonus mark. The bottom of my heart. Huh? No one know the story? Does anyone know the story? When you go through this question here. Yeah, and then question 2 is stuck around there, right? Okay, and then question 3. So question 3, we move to 3D surface, right? So you throw out a cylinder thing, okay? And then question 4. And then maybe it's like a table. Okay, yeah. From my bottom of my heart. Okay, sure. Okay, any other question to add on? Hey, if not, we still got time. We should continue with the lecture. No, later you can come back. Later, after lecture, you come back. So you just take a note. Later, I will give you mark. Don't worry. So take a photo of your quiz, and then give me back the physical copy, because your school need it for filing purpose. All right. Let's continue to catch up the. Okay, there are four example exercise here. You want to go through this or we start new stuff? Sure. How about pick show all or just pick few of them? Oh, wow. Okay. Seriously. Huh? Next time. Okay, so let's go through examples. So infinite series of n times e to the power minus n squared. What do you want to try? What test you want to try? Hello? Hey, hello. What n you want to try? What test you want to try? What n? What test? Test you want to try on this series here? So the easiest is test for divergence, right? Okay. So test of divergence, what do you get? Infinity over infinity. So you cannot see anything. So you need to do L'Hopital. So you get 1 over 2n e to the minus e to the n squared. So you get 0. Okay, so nothing. Right? Equals 0, don't know anything, right? Test for divergence, you need non-zero. So what to do? This is also not. You want to try ratio or not ratio test? Yeah, my first choice is always ratio test. Let's do ratio test. Okay. My first choice is ratio test. So set our an to be n times e to the minus n squared. Okay, so take the absolute value of an plus 1 over an, which is equal to over n to the e to the minus n squared. Okay, this looks horrible or not? Maybe not too horrible. So we can put 1 plus 1 over n here. Okay, so what happened to the e part? So we get e to the minus n squared minus 2n minus 1 over e minus n squared. So what do we get? We cancel this, then we get limit n to infinity times 1 plus 1 over n times, let's move it down because we have negative power, which is e to the 2n plus 1. What do you get? We get 1. So 1, what does 1 mean? L equals to 1. Inconclusive. So how? Integral test, good, okay? Integral test. Okay, so integral test work for what kind of function? Continuous. So okay, wait. Let me draw a conclusion here. Ratio test, absolute ratio test, absolute ratio test is in close to 1. Okay? Huh? Hey, 1 or 0? Yeah. Okay. So very good. So now we get limit. Anyone now happy or happy already? Or 1 plus 0. So, let me put here. So we expand it out so it's easier to see, okay? Okay, so we get infinity, so it's 0 plus 0, which is 0. Okay, which is less than 1. So by absolute ratio. Yes. This also converges. Okay. If you want to use integral test, I think also works. Okay. So you can try. So second method, you can try integral test. Okay, second method, you can try integral test. So what you need to do in integral test, you need to check it is continuous. Oh, no wonder just now you said 3 conditions. Is it for integral test? Yeah, you need to check continuous, positive, and decreasing on in 1 to infinity. Okay, and then you need to compute the integral of x e to the minus x squared from 1 to infinity dx. Okay, so this converges if and only if the infinite series converges. Since we already know that by absolute ratio test it converges, then that means that integral must also converges. So if you compute that the integral doesn't converge, there's something wrong in your computation. Okay. Hey, this integral is the meme I showed you last time, right? Isn't it? Yeah. No. Show both, right? I show both. Yeah. Yeah. Your memory is very good. Okay. Okay. So next, how about this one? How about this one? What can you do? This one, what can you do? What do you want to do first? Huh? What do you want to do? Huh? What test? Hey, you need to quickly decide in exam or don't have so many time on. Just decide one and then do. Okay. Train your intuition. Modular, what is modulus? Alternating series test. Okay, alternating series test. Okay, alternating series test. What do you need to check? You already have an alternating series, okay? So what do you need to check first? Bn greater or equal to Bn plus 1 for all n. Good. Limit of your Bn is equal to 0. Okay? So in Bn, what's your Bn in this case? N cubed over n to the power 4 plus 1. Okay? So be careful with these Bn, An things, right? You need to include the alternating sign or not. Okay? Need to be sure. Okay? Depends on what test you use. Alternating test, no need to include the sign anymore. You just look at the absolute value. So is it true that Bn, so is it true that n cubed over n to the power 4 plus 1 is greater or equal to n plus 1 cubed over n plus 1 to the power 4 plus 1? Yes. How do you straight away see it? The bottom become big, but the top also become big. Cannot, because you want to show for all. You need to first show for all 1. You need to try 1 to infinity. Okay. So actually you can expand it out. Okay, just expand it out. So after you expand it out, right, you get this 2n to the power 4 plus 4m cubed plus 3n squared is greater than 5. Okay, which is true. Really computed. So okay. Let me write here. So try expand. Multiply on both sides. Multiply. Yeah, try and expand it. You will get this last line if my calculation is not wrong. You can use it. You can use it. You just do the hard way. The hard way. Yeah. Yeah, you use binomial expansion for this 1, 3, 3, 1. And then this one 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. No, this is the fast way. What? I mean, you can just multiply outright if you want. Just do this multiplication. Okay. Otherwise, you use the binomial. Okay. So how about next part? So next part, I think this one is easier to see, right? So if you want to find the fraction of n cubed over n to the power 4 plus 1, what do? You divide n cubed from both, where you get n plus 1. Is that right? Yeah. So what's this? This is just 0. If you want to do L'Hopital also can. Okay, do 3 times. Huh? Also can. Also can, I think. Also can. Also can. I think also can. Also can. Also can. Yep. If you want to do L'Hopital 3 times, also can. Or 3 times also can. Okay, so these two conditions satisfied, so by alternating series test, the series converges. Okay. Okay, next, 2n over n factorial. What test you want to use? Square root test. Root test? Root test. Root test? You want to try root test? Try ratio or root test? Ratio. Yeah, try ratio. Okay, ratio test. So ratio test, what's your AN? 2n over n factorial. Okay, so you need to compute AN, the absolute value of AN plus 1 over AN, which is 2 to the power n plus 1 over n plus 1 factorial over 2 to the power. Okay, so you can cancel what? Cancel the 2 to the power n, and there we can cancel the factorial. Okay, what do we left? We left with 2 over n plus 1. Okay. Yeah. So what do you get? You get 0. 0 is less than 1. Okay. So less than 1, ratio test tells you that absolutely not just convergent, but also absolutely converges. Very good. So let's try right here. So by absolute ratio test, the series converges absolutely. Converges absolutely. Well, next one. Yes. What do you want to do with this? Hey, pro one test, we try. Need to be quick, need to be decisive. In test, I cannot think for too long. Okay. What? Test for divergence. Cannot try test for divergence. So you take the limit, what do you get? 0. So test for divergence, you need something non-zero limit. So what else? What else? Pick one. Pick one. Pick one. Geometric test. Geometric test. Geometric. But how you split the denominator? It's not numerator. Denominator how to split? Idea. Any idea? Integral test. Integral test meaning you want to integrate this guy 2 plus 3x dx. How to integrate? A bit crazy. So maybe don't want first. Keep it aside first. What else? What else? Huh? What? What's that? Comparison. Okay, sure. Compare to what? Smaller than 3 power n. Hey, close to yours, but you need to put side by side. I mean, compare them, sorry. Compare them, okay? So you saw a geometric series there, okay? See whether you can compare the geometric series or not. Because geometric series is what? Convergent, right? So you need to bound by a convergent series so that you can deduce something. So is this true? Yes, I want to see whether they know that. Why? Okay, because the bottom part is larger on the left-hand side. Okay, here is larger, so the fraction is smaller. Okay, so if the denominator is greater, the fraction is smaller. Okay, so this is true. So there's also one key point on the compared to bound below by 0. Okay, you need to bound below by 0. Okay, so what? So since the infinite series of 1 over n 1 over 3 to the power n converges by geometric series with the ratio 1 over 3, which is less than 1. Okay, by what? By ordinary or the direct comparison test. The series converges. Hey, why I put 0 here? 1 over 2. Okay. Okay, keep going. Oh, finish. Okay, new stuff. Okay. Next week. Okay. No. Next year. Why? Okay. I also don't want to see you in the same post. Don't fail, Make sure you guys don't fail. Don't fail. Okay, so we start next Wednesday power series. Hopefully we finish power series next Wednesday. Okay, so we'll end here. So please return me your quiz, and then if you need to earn mark, and then you tell me. Oh, not tip bar already give you mark, right? 1, 2, 3, 4, 5, 6, 10. Because you don't give the full solution. Okay.
Also, okay, na popular for now.
Yeah, one by one. Huh? 可以。You didn't give the full solution, so take off 1 mark, so you get plus minus 2. Then this one is 1. You want to change from so how much you get 等下什么？
就是我看那题目是范围是，然后是不是说有些是不会考到这些
啊？
是哪些不会考
Conic section
什么？
那些 3D 的那个画图那个 con 那些，
就那些什么 ellipse，
对，
包里的那些。
对。
2D 的零审不是吗？
那个 Conic 也不错。
2D、3D 也会。那有没有画 3D 的？
我不知道我不知道。 但是那些 formula 你们是不用在意了啦，重要是这些 formula
哦对对对，
我你等下考那个考。
啊，不会，没有啊，我不用签了，我已经知道了，
不用钱了。
啊，我已经知道了。
名字好啊。哦，我时间想啊。
54我就名字。
哪里啊？什么问题？
地方。
哦，OK。因为这个应该有分啊，怎么不给？3、4，对吗？4分。加4分哦，差1分是吗？
人家是没把5分到啊。
1、2、3啊。
哦，他是说你这边算错是吗？还是错吗？
他没有几别人去。
你没有错，这么他打他？
我有错啊，
你错在哪里？
我没有 factorize，
哦
没有 square 和 factorize。
哎，
是老师改。
不是老师改。
我们有个 grade。
不想 differentiate 就有分了。
可以啦，给你多1分了，
因为这个
给你多1分，给多1分啊，
入了，
啊，
多1分
对
是
那有 square root 啊。
多少分？
多1分。
因为我没有 square。
对，这个告诉我的
哦。
OK 啊，OK 啊，
还有这个
还有
2分啊，这样可怜，这个不了这个。
人家有这个，
你看
我等进去乘错，
哦，你乘进去乘错，被你乘开是对。哦，你算错一个东西，你就算错一个东西是不是？
没有乘错。
好啦，给你多1分。
哦。
原先老师。
是。这个我是写错了，这个吧，我上面有写，这个你给我多1分可以啊？
加2分。
2分。现在还没有说的好。
你这边
你前面在做，
我做对呀，我没有写完我对吧？
我没有分。
那个4分对完了，不是哎？你这边下面全部算错啊？
算对，自己算对啊。
哪一个算对？
排队。
喂，又来玩了。你没有一个是算对的，是不是？
对，
哪个判？两个都不太对。
你看我答案跟你相差是2吧，多你这个2吧。
对。
本来是我是因为我用
你的算好的，我就这个，我是他的1/2，他给我0分。
别，等下我看一下。
你是
可以，等下我一看。等下，为什么你这个算的东西跟我不一样先？
因为我没有写到，我在我上面有写。
不是，是我讲你这个 integrate 出来的东西为什么跟我不一样？怎么你后面算出来会一样，这边不一样
啊？
什么问题？怎么？你看，周末这2个
啊。
哦，你还没有乘。
他都是算一个
哦，那你乘太多。
没有他。
因为我忘记
你忘记
了
6分
啊，我有写我名的事先给他1分，
我没有分。老师，我是要写程式可以吗？
刚写完题的，刚写完题的，这被人家骗人呢。
我没有写，
我全部有写。
你发，快点发誓，快点发誓。
真的，
你不要给他打雷，发誓哦，等下打雷就是骗人了。所以我的1分。
外面直接打雷啊！
对了，加1分啊！不会骗人啊！
是我骗你，我生孩子没有屁股。
OK， 可以。
什么？你生孩子没有屁股？哎，你没有生孩子？
就是你的1/2，我求的是这一半。
很鸟。
为什么给我0分？
你做什么？我看一下。
我求的是
太酷了，
这一部分对啊，我就没有乘2而已。
我觉得你们能
那个最快1分吗？
抓，太酷了，
太酷了。
就是没有乘2而已，你给我0分。
所以我想一下
老
哦，
师快点开 Netflix 看，快点。你看你现在等哦，你就等半个小时，我们可以看半个小时。
真的。
哎，我还没有
方法 recording
啊。
Apple。
老师，你要看我剩你的 Apple 吗？哎，没有。等一下我再给。
好了没有？
我 Teams 你了吗？上这个。
我觉得我们不妙。